Okay, in this video I'm going to prove the moivres theorem using induction. Here's the moivres theorem. Really what it's saying is if we have cos theta plus I sin theta to the power of a number, well then that equals cos of that number theta plus I sin that number theta. Okay, right. So just like in most of the inductions we've done already, first step, check for n equals 1 or n equals was the first number, in this case it will be 1. So here we go. Cos theta plus I sin theta all to the power of 1 equals cos 1 theta plus I sin 1 theta. Well, cos theta plus I sin theta to the power of 1 is just cos theta plus I sin theta, and cos 1 theta is just cos theta, and I sin 1 theta is just I sin theta. So that's true. So the next step we're going to assume for n. So we have cos theta plus I sin theta to the power of k. So we assume it for n equals k. So anywhere we see n, we put in k. And we're going to assume that equals cos k theta plus I sin k theta. And that's assumed. The next step then, we want to prove it for n equals k plus 1. So anywhere I see n, I put in k plus 1. Right, let's go. So we have cos theta plus I sin theta to the power of k plus 1. That equals cos k plus 1 theta plus I sin k plus 1 theta. Okay, what I need to do now is I need to make this side over here look like this side here, and if they look the exact same, well then I've proved it. The first thing I'll do is I'm going to take this side and I'm going to start maneuvering this side, and in the end hopefully it'll look like that side. Right, so cos theta plus I sin theta is the power of k plus 1. Well, that's the same as cos theta plus I sin theta to the power of k multiplied by cos theta plus I sin theta to the power of 1. And using the moivres theorem, I can say that that is cos k, we got the brackets actually, cos k theta plus I sin k theta multiplied by cos 1 theta, which is just theta, plus I sin 1 theta, which is again just theta. Again, I want to make this look like that, but it doesn't look like it so far. So now I'm just going to multiply it out. I'm going to multiply cos k theta by cos theta, and I will get cos k theta cos theta. And next I have the cos k theta by the I sin theta. And that's just plus cos k theta I sin theta. And the next one is this by this. So it's plus I sin k theta cos theta. And the last one, I sin k theta by I sin theta. Well, the I by I will give me the I squared, and then I have sine k theta sine theta. Notice we have an I squared, which really is minus 1, or in other words, we drop the I squared and we change that sign. So I'll do that. So we get cos k theta cos theta plus cos k theta I sine theta plus I sine k theta cos theta minus, and drop the I squared, k theta sine theta. Okay, next one I'm going to do is I'm going to group this long thing into its real and its imaginary components. So its real bits are anything without an I. So that's real and that's real. So we have cos k theta cos theta minus sine k theta sine theta. We also have our imaginary parts, which are here and here. I'm going to group those together, but I'm going to take out the I. Right, so I'll have plus I, and this bit here I have cos k theta sine theta plus sine k theta cos theta. Again, all of this does not look very much like this, not so far anyway. However, if we look at in our logbooks, you'll see this. You'll see cos a plus b equals cos a cos b minus sine a sine b. You'll also see sine a plus b equals cos a sine b plus sine a cos b. So that's in your logbooks. You don't need to know that off by heart. And that's just something we know. Right, using that information though, let's have a look here. Cos A, cos B. Well look, here's a cos and a cos. So I could say that this k theta is A and this theta is B. Likewise here, sine k theta minus sine theta. Well look, that's that bit. Okay, so if you just look again, see all of this. And that's basically exactly like this. I just have to call the k theta A and the theta B. That goes over here. The k theta is A, the theta is B. So I have this up here. So basically I can say, well, okay, that's the same as cos A. Now what did I say A was? K theta plus the B I said was theta. So I've that bit done. I've that bit simplified to this. Let's look over here now. I've cos k theta sine theta plus sine k theta cos theta. Look at this. cos A sine B sine A plus sine A cos B. That is the same as that if I replace the k theta again by A sine theta by B, k theta by A sine theta by B. And I can say plus I sine k theta, which is A, plus theta, which is B. If I just factorize out the thetas now, I have cos, now factorize out the theta and I get k, factorize out the theta, I get plus 1 theta outside. So that is the same as that really. I just factorized out the theta. So look at this, theta by k, it's k theta, theta by 1 is theta. Plus I sine, factorize out the theta again, k plus 1 theta. And we don't need the brackets. Okay, just say that. Now, I have cos k plus 1 theta plus I sine k plus 1 theta. Does that look like this? Yes, it does. Sorry, here. Does that look like that? Yes, it does. So now I'm after proving that this, in fact, is the same as this. So I can say, therefore, if we go back up here, cos theta plus I sine theta plus n equals cos A theta plus I sine n theta. Okay, so I'm after proof it. That's it, guys. You need to go over this and over it and over it. You need to learn it. You need to know it off by heart. Okay, it's a popular question. Okay, thanks.